In this video, we're going to discuss how to solve polynomial equations. So a polynomial equation is going to have various terms with x raised to a positive exponent. And so the first thing we're going to want to do is add or subtract the sum of the terms so that one side is 0. And then that way we can factor the other side and solve using the zero product property. So here's our first example. We have 3x squared equals negative 6x to the fourth. And so I'm going to add the 6x to the fourth to both sides. You can put the terms on whichever side you want. I usually like to have the term with the highest exponent have a positive coefficient. I think that's a little bit easier. So these aren't like terms. We can't combine them. We're just going to write it as 6x to the fourth plus 3x squared equals 0. And now that that side is 0, we can factor. We have two terms on the left side. There's our plus sign separating our two terms. And we can just look for a greatest common factor. So both coefficients are divisible by 3. And both terms have an exponent on the variable of at least 2. So we can factor out an x squared as well. And then the first term, we're going to be left with 2x squared, because if we multiplied 3x squared times 2x squared, we would get 6x to the fourth. And then don't forget about the second term. There should still be two terms left in the parentheses here when we're done factoring. 3x squared times 1 is 3x squared. And so now that this has been factored and it equals 0, we can set each factor equal to 0. All right, so if we divide both sides by 3 here, we have x squared equals 0. So the only solution there is going to be 0. Over here, we can subtract 1 and then divide by 2. So we have x squared equals negative 1/2. We can just use the square root property there to solve that. Take the square root of each side. We should get two solutions, plus or minus there. And since we're taking the square root of a negative number, these are non-real solutions. We can't square a real number and end up with something negative. So we're going to write these using I. So this is plus or minus I times the square root of positive 1/2. And square root of 1 is 1. So we could write this as plus or minus I times 1 over the square root of 2. We ended up with 3 solutions here. We had 0, and then we had these two non-real ones over here. The most we can ever have is whatever the highest degree is. So here the highest exponent on the variable was 4, so we would definitely not have any more than 4 solutions. But in this case, as we see here, we did have fewer than 4. All right, with this one, we have degree 3, so we're going to have at most 3 solutions. And again, we want to start by getting all the terms on the same side and factoring. So I'm going to subtract these so that my x cubed term stays positive. So I'm going to subtract 5x from both sides and subtract 15 from both sides. None of these terms on the left are like terms. They all have different exponents, so we can't combine any of them. So we just have to leave it like that. And then we're going to factor by grouping since there's 4 terms. So when we solved quadratic equations by factoring, we would split up that middle term so that there were 4 terms, and then we factored by grouping. So essentially here it's like the middle term's already been split, we have 4 terms, and so now we can just look and see, all right, what do the first 2 terms have in common? They both have an x squared, so we can factor that out. We'll be left with x plus 3. And then if we look at the second pair of terms, it looks like we could factor out a 5 or a negative 5, and we want to choose carefully there. We want to make sure that what's left in the parentheses from the second pair of terms is the same as what was left in the parentheses for the first pair of terms. So we want to be left with positive x and positive 3, so we need to factor out a negative, because then we're dividing each term by negative 5, and we'll be left with a positive result for both terms. All right, now it's like we have 2 terms on the left. There's our subtraction symbol separating our 2 terms. And so both terms have a factor of x plus 3. So now that's our common factor that we're going to factor from each term. The first term is left with x squared, and the second term is left with minus 5. And so now, since these 2 factors multiplied together equals 0, we know one of them must be 0 in order for that to be the case. That's why you don't want to factor until the other side is 0, because if 2 numbers multiply together and you get anything other than 0, you don't really know anything about those 2 numbers. But if 2 things multiplied together gives you 0, you know one of them has to be 0. All right, over here we're going to get x equals negative 3. And here, if we add 5, we have x squared equals 5. And then we can solve with the square root property there. We want to make sure that we remember there's 2 solutions. There's 2 real numbers we can square to get positive 5. There's the square root of 5 and negative square root of 5. So here we get 3 solutions for our degree 3 polynomial equation. We have negative 3, square root of 5, and negative square root of 5. Let's do one more example like that. Again, I want to reemphasize this here. You don't want to start factoring this yet, because if I know 2 numbers multiply to give me 200, I don't know anything about those 2 numbers. Is it 100 times 2? Is it 10 times 20? I don't know, right? But if 2 numbers multiply together and give you 0, you know it had to be 0 times something. That's why we can set each factor equal to 0 when we're done with that process. So we want to start by getting one side to be 0 always before we factor any equation. So here I'm just going to subtract the 200. And there's no other constant term on the left side there, so I can't combine it with anything. But that's okay because we have 4 terms, so we're going to use our factoring by grouping process here. The coefficients for the first pair of terms don't have anything in common, but they do both have an x squared, so we can factor that. And we're going to be left with 3x minus 2. And then if we look at our second pair of terms here, looks like both of those coefficients are divisible by 100. And we want to factor out positive 100 because we do want the first term to be positive and the second term to be negative, because we're trying to be left with 3x minus 2 again. So if we factor out positive 100, the signs will stay the way they are now. We'll be left with 3x minus 2. Okay, now we have 2 terms separated by this plus sign here, and both of the terms have a 3x minus 2. So we can factor that from each term. First term here is left with an x squared, And the second term is left with a plus 100. Okay, now the left side's factored, the right side is 0, so we can set each factor equal to 0. And for the first one, we can just add 2 and divide by 3, and we'll have x equals 2/3. Be careful with the second one. To get x squared by itself, we need to subtract 100. So we end up with x squared equals negative 100. That means we have non-real solutions from this part, because you can't square a real number and get something negative. We are still going to get 2 solutions though. Anytime you have x squared equals a number, you're going to get 2 solutions unless it's x squared equals 0. Then you just get 0. But don't forget that plus or minus there so that you remember there are 2 solutions. Plus or minus square root of negative 100. And since this is a non-real number, since it's a square root of a negative number, we do want to write that using I. So it's plus or minus I times the square root of positive 100. And the square root of 100 is 10. So we can just write this as plus or minus 10I. So we had 3 solutions for this equation as well. We had 2/3, 10I, and negative 10I.